Excellent. We have the cosine of y plus 6 is equal to x. Again, we could solve for y, but here we're just going to go ahead and take the derivative on both sides. Right? Again, y is a function of x implicitly by the implicit functions theorem, so the derivative of cosine of y is negative sine of y times y prime, or in this case, they like using the form dy dx instead of y prime. We'll use their terminology, dy dx plus the derivative of 6 is 0 equals the derivative of x, which is 1. And we're solving for dy dx. Negative sine y times dy dx is equal to 1, and dy dx is equal to dividing negative 1 over sine y. I also think my math lab is going to take negative cosecant of y. Either one should work. Floor will be open for questions at any moment. Take the derivative on both sides, solve for dy dx. Y cubed is equal to 20x. I could take the key root on both sides and then take the derivative, or I could do this implicitly. The derivative of y cubed is 3y squared times dy dx. The derivative of 20x is 20, and therefore dy dx is equal to 20 over 3y squared. That's legit. If I wanted to know the slope at 50, 10, that means x is 50. There are no x's, but the y is 10. And so at the point 50, 10, it's going to be 20 over 3 times 10 squared. 20 over 300, 2 over 30, 1 over 15. I got 8, well, I'm just going to get there now. 8x to the 1/2 minus 9y to the 1/2 equals 23. I'm just going to dump these roots and just put the fractions there because I intend to use the power rule. First step is to take a derivative on both sides. Half of 8 is 4. 4x, subtract 1 from the power, negative 1/2. Minus 9 over 2, y to the negative 1/2, times the derivative of y equals the derivative of 23. We're solving for dy dx. So I'm going to move this over here. So then dy dx equals negative 4x to the minus 1/2 over negative 9 over 2x. I'm sorry, that's y to the minus 1/2. I'm worried about my math lab, right? So there's some algebra to do to show that things flip. Negative exponents move. And so one can show that this is 8y to the 1/2 over 9x to the 1/2. I'll take any questions about that algebra. The negative exponents leave the denominator or numerator respectively, and then negative 4 over negative 9 over 2 reduces to 8 over 9. 8 square root of y over 9 square root of x. At the point 16, 1, That's 8 times the square root of 1 over 9 times the square root of 16. 2 over 9. We might have enough space for this, but I'm going to assume that we don't have it. Four cosine xy equals 7x plus 5y. Again, the first step is take the derivative on both sides. The derivative of 4 cosine xy is negative 4 sine of xy times the derivative of xy, and that requires the product rule. I need u prime v plus v prime u, and so this is going to be equal to 1, the derivative of x is 1 times y, plus dy dx times x. And so the derivative of 7x is 7, and the derivative of 5y is 5 times the derivative of y. Right? So this is one of the ugly ones. I don't care how ugly it is. I know what my goal is, and it's to solve for dy dx. Got to get it by itself. So we got to unravel all of this stuff. So we'll distribute here. So we've got, I knew I didn't have enough room. Minus 4 sine of xy times y, this times this, and then minus 4x sine of xy times dy dx equals 7 plus 5 times dy dx. Again, solving for these. And at this step, once everything's been out, we're going to get all the dy dx's on one side, everything else on the other side. We'll factor out and we'll divide. So then I've got minus 4x sine of xy times dy dx minus 5 times dy dx. I'm just going to be a gangster about it and just move everything to the left. Abiding by the rules of mathematics, of course. And then on the other side, I've got a 7 chilling out there, and then 4y, the sine of xy. Still solving for this. They both have that in common. That's not by coincidence. We'll factor it out, dy dx times negative 4x sine xy minus 5 equals 7 plus 4y sine xy. And then the final step is to divide. Dy dx equals 7 plus 4y sine of xy all over negative 4x sine xy minus 5. Super ugly. The crucial part here is recognizing that this requires the product rule. All right, but what steps are we talking about? We're talking about taking the derivative on both sides, applying the product and chain rule as necessary, and then once you do that, seeing how many dy dx's you have. And again, the number of dy dx's matches the number of times y appears. So when you get to this step, you should say, okay, do I have 2 dy dx's? You do, and now it's time to go ahead and solve for them. Something similar happens here. When I have e to the xy equals 3y, we might be able to fit this one in. Take the derivative on both sides. It's e to the xy times the derivative of xy, which again is the product rule, which is 1 times y plus x times dy dx. That equals the derivative of 3y is 3 times the derivative of y with respect to x. We'll distribute again y e to the xy plus x e to the xy dy dx equals 3 dy dx. We'll get them all on one side, factor out, and divide. So then you're going to have x e to the xy dy dx minus 3 dy dx equals negative y e to the xy. So then dy dx times x e to the xy minus 3 equals negative y e to the xy. And then we'll divide. Dy dx equals negative y e to the xy all over x e to the xy minus 3. And that goes here. Sine of 4y squared plus 5x equals 9e to the y. We'll use purple. The derivative of sine is cosine of 4y squared times the derivative of 4y squared, which is 8y times dy dx. Plus the derivative of 5x is 5 equals the derivative of 9e to the y is 9e to the y times dy dx. Got 2 dy dx's, and then we just get to work here, right? So then you've got cosine, we got 8y cosine 4y squared times dy dx minus 9e to the y times dy dx equals negative 5. And we'll factor and divide. This means that dy dx is equal to 5 over 8y cosine 4y squared minus 9e to the y. And that is a negative 5. Tedious. But we got to do it once. Not enough space here for this one. Same issue here. Here, product rule. We'll take a derivative on both sides. The derivative of 8x to the fourth is 32x to the third plus 28y to the third times dy dx. And that needs to be equal to 15y plus 15x dy dx. Solving for dy dx, same idea. You got 28y cubed dy dx plus it's minus 15x dy dx equals 15y minus 20 minus 32x cubed. Factor out and divide dy dx times 28y cubed minus 15x equals 15y minus 32x cubed. And so dy dx equals 15y minus 32x cubed over 28y cubed minus 15x. Questions there. Product rule, quotient rule, same idea. We did these a little bit using logarithmic differentiation. So when it says use logarithmic differentiation, we'll go through these steps. That means you do this first. Number one, you set y equal to the function. So you do y equals x to the 4x. And then two, you take the log on both sides. Three, use a log rule that brings the power in front. And notice we have yet to take a derivative, and then we take a derivative. Right? Right. Right. So now I've got the natural log of y is equal to 4x, the natural log of x. And now taking a derivative of that, remember we're looking for y prime. We'll use a different color here. So then take a derivative. The derivative of the natural log of y is 1 over y times y prime. And that equals, and here again we are with the product rule. It's 4 times the natural log of x plus 4x times the derivative of the natural log of x is 1 over x. So 1 over y times dy dx is equal to 4 natural log of x, and then 4x times 1 over x is 4x over x. The x is canceled. That's 4. I'm solving for this. Currently multiplying by this or dividing by y, I just multiply y on both sides. So dy dx is equal to y times 4 natural log of x plus 4, and we'll just remember that y was x to the 4x. X to the 4x power times 4 natural log of x plus 4. Right, so steps are there. Set y equals to the function, take the natural log on both sides, bring the power in front, take the derivative on both sides, and then do whatever it takes to find what y prime is. All in the tools. Do that a couple more times before we get to some inverse trig functions. So when it says use logarithmic differentiation, that's what we're doing. Start with number 9, y equals x plus 4 to the 11th, 4x minus 8 to the 12th. The answer to this looks like a monster, right? So first step, we'll take the log on both sides. ln of y equals ln of x plus 4 to the 11th over 4x minus 8 to the 12th. Number 2 is use the log rules. This means that the natural log of y is equal to, and we can talk about later that this is 11 ln x plus 4 minus 12 ln of 4x minus 8. Right? So again, that's using again that the ln of a over b is the natural log of a minus the natural log of b, and all exponents come to the front of logs. Now that we have this in a nice simplified way, we can then take the derivative on both sides. The derivative of the natural log of y is always the same thing. It's 1 over y times y prime dy dx. And then this right-hand side, the whole point of taking the log is that now, once we take this derivative, it's supposed to be nicer, and it is. The derivative of 11 natural log of x plus 4 is hold the 11 times 1 over x plus 4 times the derivative of x plus 4, which is 1. Minus 12 times the derivative of the natural log of 4x minus 8 is 1 over 4x minus 8 times the derivative of 4x minus 8, which is 4. This means that 1 over y dy dx is equal to 11 over x plus 4 minus 48 over 4x minus 8. I'm solving for dy dx. I'm going to multiply by y. And then remember what y is. 11 over x plus 4 minus 48 over 4x minus 8. And that y was that ugly thing. X plus 4 to the 11th over 4x minus 8 to the 12th. That is the derivative. For number 10, same thing, y equals 2x, all raised to the natural log of 2x. We'll do the natural log of y on both sides. Natural log of y equals the natural log of 2x raised to the natural log of 2x. This entire power comes out in front. Natural log of y equals the natural log of 2x times the natural log of 2x. We could use the product rule here, but I do want to observe that this is the natural log of 2x all squared, and we can use the chain rule. We'll take a derivative now. The derivative of the natural log of y is 1 over y times y prime. The derivative of the natural log of 2x to the second is 2 times the natural log of 2x to the first times the derivative of the natural log of 2x, which is 1 over 2x, times the derivative of 2x, which is 2. I couldn't help but write y prime. 1 over y times dy dx is equal to 2 ln of 2x all over x. But these 2's cancel. And finally, dy, or semi-finally, dy dx is equal to y times 2 ln 2x over 2. And we just have to remember that y was 2x to the natural log of x. 2x. So 2x to the ln 2x times 2 ln 2x all over x. So super funky answers. Just making sure that we're entering stuff in very carefully into my lab. We'll close these by just doing differentiation of inverse trig functions. What's the slope of the line tangent to the curve of y equals inverse tangent of negative x at x equals negative 2? Slope of the tangent line, they just want to know the derivative at negative 2. Well, we know that the derivative of the inverse tangent of u is 1 over 1 plus u squared times the derivative of u. So this is going to be 1 over 1 plus negative x squared times the derivative of negative x, which is negative 1. This is negative 1 over 1 plus x squared, and we wanted to know this value at negative 2. At negative 2, it's negative 1 over 1 plus negative 2 squared. Negative 1 over 1 plus 4, negative 1 over 5. The derivative of the inverse sine of u is 1 over the square root of 1 minus u squared times u prime. U in this case is 8x to the third. So it's 1 over the square root of 1 minus 8x to the third squared times the derivative of 8x to the third, which is 24x squared. Here, product rule, u prime is 12, v prime is 1 over the square root of 1 minus x squared. The derivative of uv is u prime v plus v prime u. U prime is 12 times v, inverse sine of x, plus v prime, 1 over the square root of 1 minus x squared, times u, 12x. We're not afraid of this. The derivative of the sine of the cosine inverse of 7w. Well, just remember that the derivative of the cosine, inverse cosine of u is negative 1 over the square root of 1 minus u squared. And so the derivative of the sine of inverse cosine of 7w is the cosine of inverse cosine of 7w times the derivative of inverse cosine of 7w, which is negative 1 over the square root of 1 minus 7w squared, times the derivative of 7w, which is 7. Now, they might be trying to be fancy here. Hopefully you can put this into MyLab. But we'll notice that the cosine of the inverse cosine of 7w, well, if they're inverses, these things should cancel, and this should just be 7w. And so if you want to write this in a fancy way, it's negative 49w over the square root of 1 minus 49w squared. It should take either one. The derivative of 6 times inverse tangent of 6x, just remembering the rule, 1 over 1 plus u squared times u prime. That's going to be 6 times 1 over 1 plus 6x squared times the derivative of 6x, which is 6, 36 over 1 plus 36x squared. Let's get a new sheet. Putting it all together. The derivative of the natural log of the inverse tangent of 9x to the fifth. The derivative of the inverse tangent of u is 1 over, the derivative of that is 1 over 1 plus u squared times u prime. And so the derivative of the natural log of that is 1 over inverse tangent of 9x to the fifth times the derivative of inverse tangent of 9x to the fifth, which is 1 over 1 plus 9x to the fifth squared times the derivative of 9x to the fifth, which is 45x to the fourth. Here we might be able to manage this one on this page. This is going to be 9 times 1 over, let me look at this other one. Yeah, great. 9 times 1 over 1 plus e to the 11x squared times the derivative of e to the 11x, which is 11 e, well, let's do it this way, which is e to the 11x times the derivative of 11x, which is 11. And here we can do 99 e to the 11x over 1 plus e to the 22x. For the game. Find an equation of the line tangent to the graph of y equals 1/3 inverse tangent of 1/5 x at the point 5 comma pi over 12. y minus y1 equals m times x minus x1. Y minus y1 equals m times x minus x1. Find the equation of the tangent line. Right, so step 1, got the point, x1 is 5, y1 is pi over 12. We need the derivative for m. Y prime equals 1/3 times 1 over 1 plus 1 over 5 x squared times the derivative of 1 over 5x, which is 1 over 5. I want to know this at 5. Y prime at 5 is the slope I'm looking for. This is 1 over 3 times 1 over 1 plus 1 squared times 1 over 5. This is 1 over 3 times 1 over 2 times 1 over 5, 1 over 30. That's the game. Y minus pi over 12 equals 1 over 30 times x minus 5. They want y equals 1 over 30 times x minus 5 plus pi over 12. I'll end the recording there. Open the floor for any questions.